And I am Akilapriyadharshini from Department of Civil, VSB Engineering College, Karur. And today we are going to see about the Unit 4 Rehabilitation and Strengthening Techniques. And in this unit, we are going to see about the seismic retrofitting, strengthening of beams, strengthening of columns, strengthening of slabs, strengthening of masonry walls, protection method of structures, mud jacking, and grouting for foundation, micropiling and underpinning for strengthening floors and shallow profile, and subgrade waterproofing and soil stabilization techniques. And while coming to this unit, we have an intro. When we can have an intro, it is just a rehabilitation includes evaluation and assessment of the existing structure to identify the damage or weakness that is attained in the structure itself. And strengthening focuses on carrying the capacity and resistance of the structure, and by using steel brace or reinforced concrete members, we are making it more strength when compared to the previous one. And seismic retrofitting is displacement from the structure concrete foundation and making it to a safer and less suffer damage during an earthquake. While having an earthquake, it is more considered to save the structure likely to suffer damage during an earthquake. And then here we have types of retrofittings or jacket of beams, jacket of beam column joints, strengthening individuals, and jacketing of columns. And then we are coming to the steel jacketing. We are just providing some additional steel plates or sections the existing beam to enhance their strength and stiffness, and it increases the load bearing capacity of the beam. And assessment is based on the design where the load carrying capacity is vulnerable to seismic forces, and design is based on the assessment of a steel jacketing system and surface whether we have to clean or prepare to ensure the proper bond between the steel plates and in the existing concrete. And then steel plate installation is to cut the required part by rounding the sides of the bottom of the beam. And then by using these steel jacketing, we have some benefit. It can increase the load carrying capacity, and it provides an improved ductility and enhances shear and bending strength, which is highly generated to earthquakes. And preservation of existing architecture. We are giving some appearance or architectural feature without um, uh, altering the appearances, preservation of existing architecture, and relatively it gives quick and efficient retrofitting. And a FRP is fiber reinforced polymer wrapping, is a carbon glass material to wrap them around to provide an additional strength and to give confinement. And it involves an applying of layer to the FRP polymer material, such as carbon or glass fibers, to surface them and to enhance the resistance to seismic force. And it has several benefits of high strength to weight ratio, where strength is attained with the while being of lightweight, and then excellent corrosion material due to of fibers that is placed that is present in the FRP, and then the increased flexural and shear strength. And it also has a continuous improved quality and a compatibility with existing structures, and minimal distribution during disruption during installation, and agricultural flexibility, and it provides a long service life. By using this FOP material, we can have excellent durability and resistance to environmental factors. And then coming to this concrete jacking, where concrete is applied around the existing beam to enhance its load carrying capacity, and it is of ductility one, and it is of a common of seismic retrofitting method used in beams of the existing structures. And increased load carrying capacity, it provides a main advantage, and it improves the ductility and enhance the bending strength and shear strength. And fire resistance also, while compared to the existing. And following are the benefits that are attained due to seismo retrofitting and strengthening of beams, improved structural performance, and it enhances safety and preservation of the existing structure. And challenges and problems associated with the seismic retrofittings are cost effect. It requires a more cost, and disruption and time is considered and design complexity is made. And then strengthening of columns. Here the column is completely strengthened by using this technique, where the first one is steel jacketing, which involves of adding steel plates or sections around the column to enhance its strength and stiffness. And by using these, we have the benefits of enhanced ductility and provide improved shear and bending strength. And FRP wrapping. In this image, the FRP wrapping is done. It is similar to the beam retrofitting. It is here done for a column, and it enhances strength, ductility, and improves performance during seismic events. And advantages are high strength to weight ratio, excellent corrosion resistance, and increased flexural and shear strength. And uh, and it provides a long service life by using these column retrofitting and concrete jacking, where steel of adding a layer of reinforcement in the existing column, and concreting is done towards the reinforcement to make the column more stiffness. And advantages are, as usual, we can enhance the shear and bending strength, and improved quality is done, and concrete compression is also achieved, and it is of fire resistance, and we are not disturbing any the existing structure, and we are giving extra strength to the existing column. And then steel bracing or adding steel elements such as braces or struts and provides additional support and stiffness to the column, reducing it during earthquakes. And advantages are improved strength and stiffness, improved resistance to lateral force, and then energy dissipation, where the energy absorbs and dissipates transmitted to the column during the earthquake times. And it is of a quick and cost effective solution, and adjustable and retrofit friendly. And then while considering to the design flexibility, it plays a main role. Our architectural and basing elements are positioned and as strategically to address high stress or vulnerability. And then it enhances the ductility and increase the resistance to lateral force and preservation of structural integrity and enhance its safety. And it is of cost expensive, and destructive time is considered here. And some common additional methods are adding reinforcement to the slab and providing some extra strength to the slab. And it has some advantage. It provides a increased strength and improved ductility and enhanced crack control and better load distribution. And cost effective solution and preservation of existing slab, we just minimize the disruption of to building occupants and reduce the need for extensive demolition, and it results quicker and more efficient retrofitting process. And composite materials, that is fiber reinforced polymers, are used to the surface of slab to enhance the structural performance and making them effective for slab strengthening. And by using this, we can attain flexibility in design, durability, and improved crack control and increased stiffness, and quick and non-disruptive installation is done. And then installing steel bars or shear walls. We are just installing beneath to increase the stiffness and resistance to the lateral forces, installing steel bracing or shear walls. And it provide additional support and help to distribute the seismic loads. And installing the steel bars or shear walls is commonly used for the installation of steel elements for the installation of steel elements such as braces or walls, and to provide stiffness and resistance to the lateral force. And these are all the factors for installing the steel bars or shear walls, where first one is increased stiffness and improved load distribution and enhances the resistance to lateral force and energy dissipation and flexibility in design, and then quick and efficient installation and adjustable and retrofitting friendly. And then they have some advantages of increased stiffness, improved load distribution, and enhanced resistance to lateral force. and then it is adjustable to retrofit friendly and cost effective solution. Here it is considered in a big manner, where the design and fabrication of steel walls it is carried out by experiencing engineers, and proper analysis is done for the cost effective solution. And adding moss or damping device, helps to absorb and dissipate seismic energy and reduce the force transmitted to the slab. And here we are providing where the elongation is made and the dissipation of energy and the seismic energy is reduced here. And by using these, we have some advantages: energy dissipation and reduction of resonance effect, and increased stability, improved seismic performance and tunnability. And adding of mass and damage have a high versatility and cost effectiveness. And by using this, we can increase the load carrying capacity and reduce the structural damage. And challenges and considerations associated with the seismic retrofitting of slabs. And it provides high accessibility and disruption and cost and design complexity. And strengthening of masonry walls, here we are strengthening the masonry walls and they are able to resist the seismic forces where it is commonly of earthquake damage. And here we are strengthening by using some additional reinforcement which provides the wall strength and improve its resistance to seismic force. And then it has the advantage of increased strength, improved ductility, enhanced crack control, improved load carrying capacity, and seismic energy dissipation, and preservation of aesthetic and architectural structures. And here we are coming with grouting, and we are injecting the grouting material and making it to attain the strength in a good manner. And grouting involves of injecting the mortar into the gaps where we can find the voids. And by using this, we can improve the stability, cohesion, and resistance to the seismic force. And by using these grouting, we can enhance the performance of massive and reduction of wall collapse during the seismic activity. And here provides the advantage, and it is of cost effective, and improved crack control is achieved, and increased stiffness and rigidity is achieved here. And shear walls are vertical structural elements and provide stability to the buildings and to withstand during the seismic force. And it is commonly for retrofitting method where to strengthen the masonry walls, this method is used. The advantages of shear wall construction as a masonry wall is to increase the load, improved load distribution, and enhance ductility and improved structural integrity. And versatility is achieved by maintaining the shear walls as a masonry walls. And then by methods of strengthening of masonry walls is by using external steel basing, FRP wrapping, and shotcrete or concrete jacking. And benefits of these strengthenings are increased structural strength, improved ductility, and preservedness of historical structures. And these repairs are mainly made to maintain the architectural purpose and monument structures. And challenges of strengthening is structural assessment, compatibility, and cost and disruption. We can't spend more money in cost for the repair and maintenance, and so we are considering cost in a main manner, and we are achieving the cost is front, and the challenges are faced by considering these costs. And first one is common protection methods used for structural seismic protection is base isolation by providing the foundation between the building and the superstructure, and by reducing the structural damage. And then energy dissipation device like dampers and absorb dissipate seismic energy and to impact the structure and to prevent excessive deformation or collapse during earthquakes. And third one is fire protection and using of fire resistant material in construction such as fire roof coatings and suppression systems like alarms, and compartmentalization as dividing the building into pods of fire resistant walls and to control the spread of fires in a rapid speed. And flood protection where we are using flood barriers or flood walls to prevent the intrusion into the building of water, and flood proofing as of elective We are just avoiding the material like electrical and mechanical system from water, and providing some proper drainage system will help for the seismic protections. And then wind and hurricane protection by considering the wind load analysis, and then Toronto safe rooms where we can have a sub-base rooms that is safe from the wind and hurricane protections. And blast protection, when they are comparing, when they are going with some blast purpose, we can have some blast design to protect ourselves, and we are just absorbing the energy of exclusion and reduction of reducing the structure to be collapse from. And security protection, we are providing some surveillance systems and access controls by using biometric or monitoring the CCTVs, and we are achieving the seismic protection by ensuring these methods. And mud jacking and grouting for foundation, it is also known as slab jacking or concrete lifting to raise the sunk-end concrete wall. It involves the injection of cement balls and beneath the sunken slab to lift back to the original position. And then cause of sunken or soil consolidation, poor soil compaction and erosion, and proper poor drainage systems. And then this process of mudjacking includes preparations and drilling holes where we have to do the mudjacking, and then injection ports installed. Once the injection ports installed, we are going to mix the mud, and then the mud is injected and lifting the slab. With lifting the slab, we are just seal and clean up, and curing is done. And application of mudjacking is for concrete slabs and foundations to strengthen it. And then the advantages are cost effective, long lasting results, and environmental friendly. And micropiling for strengthening floors and shallow profile. And here it goes with the small diameter piles ranging of material 100 mm to 300 mm, and it provides additional support and stability. And here we can see the micropiling techniques where we are giving some additional groove to make it a strength, and by using a drilling rod. And by using the process includes the site investigation, design, installation, connection, and load testing. And then by advantages of micropiling are time efficient, cost effective, high load capacity, versatility, and minimal site distribution. And then underpinning for strengthening flows and shallow profile. Underpinning is a technique used to strengthen floors and shallow foundation, and by increasing the load bearing capacity. It involves support to existing foundation and experience proper settlement or insufficient strength. And causes are weak or unstable, and the settlement is not properly done, and changes of the surrounding environment. And process of underpinning, or first it goes with site investigation, and then once the site investigation done, the excavation is done. After excavation, the installation of supports and underpinning techniques. We have some proper techniques that is going to use, and micro piles, moss concrete underpinning is done, and then mini piling, jet grouting, micro piles, and load transfer and completion is done here. And applications are foundation rehabilitation and structural upgrades. And advantages of underpinning are increased load bearing capacity and stability and durability, customizable solutions, and potential for future modifications. And subgrade waterproofing, here the subgrade waterproofing is application of waterproofing material to protect the subgrade. It is highly essential for components of building construction high with high water tables and poor soil drainage. And then the purpose is to prevent water infiltration and to enhance the structural integrity, and enhance indoor comfort. And methods are external waterproofing membranes, bentonite waterproofing, cementitious coating, liquid applied membranes, drainage systems. The advantages is increase energy efficiency, long-term cost savings, protection against water damage, and then the soil stabilization includes to enhance soil strength, reduce settlement, and improve its ability to withstand applied loads. And techniques are compaction and chemical stabilization is done by lime stabilization, cement stabilization, and fly ash stabilization. And here we can apply the techniques of grooting and geosynthesis. And then soil mixing is done, whereas it is done by cement deep soil mixing and lime columns. And the benefits of soil stabilization is to increase the load bearing capacity of the soil and reduce the settlement and potential and improved stability and increased slope stability and prevention of landslides, and it is of cost effective when compared to alternate methods of replacement. And by studying this unit we can go with rehabilitation and strengthening of columns, beams, and by soil stabilization we can increase the foundation strength where the water table is of high profile and low soil, and everything is covered in this unit. By studying this unit we can strengthen our architectural and monument structure.